Okay, AP Computer Science A. This is a continuation of the multiple choice Unit 1 packet. So let me do the last part of it. Let's see, 19 in Java, a variable of type int is represented internally as a 32-bit signed integer. Suppose that one bit stores the sign and the other 31 bits store the magnitude of the number in base 2 binary. In this scheme, what is the largest value that can be stored as type int? So the idea is that the biggest value would be 2 to the highest power, but since one of them stores the sign, you're going to get 2 to the 31. But also 0 is one of the numbers, so we got to take away 1 for that to hold the 0. So it starts at 0, and so 2 to 31 minus 1. So this is just something you could look up. It's just the way it stores numbers, and the largest number it can store. But we have to take 1 away for the sign and 1 away for 0. And this is just kind of going back to these other types of numbers, you need, 1 bit for each of these coefficients, right? And so if you're going to use 32 bits, each one of these will be a coefficient. Let's see, consider this code segment. Int equals 10, y equals 0, while x is greater than 5. So what will be the output after the execution of this? So while x is 10, we could kind of maybe try and, I don't know if there's a way to, let's see. Okay, so while x is 10, then y equals 3. So now y equals 3. While 3 is less than 10, which is true. So that's true. Then y times equals, that's the same as y equals y times 2. So it's 3, so now it's going to be 6. I guess maybe a way to keep track of this is we have our x values and we have our y values. And currently x is 10 and y is 0 at the beginning. But then 0 becomes 3. And now 0 is, now y becomes 3. Now y is 6. It says while y modulus. So this is going to be 6 modulus 10. Well, that remainder is 6 because 10 doesn't go in. So this is false. So that doesn't happen. So then we go down here and x gets set to x minus equals 3. So that's the same as x equals x minus 3. And x is 10 right now, so minus 3 would be 7. Let's see. Okay, so I think that would be the next value. Now I have something else written here. Hold on a second. Oh, okay. Oh, hold on. I skipped something. So this was false first. Then it goes back up here and it says, and now y is 6, and 6 is less than 10. So it multiplies itself, and now it's 12. It goes back up here and says, well, is 12 less than 10? Nope. So then we come down here, and x is now 7. Y hasn't changed. Y is still 12. And so we come all the way back up here and say, okay, well, is 7 greater than 5? Yep. Then y equals 3. So now y gets set back to 3. It was 12. Y gets set back to 3 again. And then it says, okay, well, is 3 less than x, which is 7? Yep. So then y gets doubled. and now it's 6. And then it's going to be 6 modulus 7, which does not have a remainder of 1. It has a remainder of 6 again, so that doesn't happen. Goes back up here and says, okay, well, is 6 less than 7? Yep. So it gets doubled again. And then it gets checked is 12 modulus 7 equal to 1. Nope, it's 5, so that doesn't happen. And so it comes back up here. Is 12 less than 7? Nope. It comes down to here. And x is going to equal itself minus 3. And right now it is 7. 7 minus 3 is 4. So now x equals 4. Goes back up to the top. Is 4 greater than 5? Nope. So we're done. And then it prints x and y out. So what were the last values? It's going to print 4 and 12. That's what it's going to print, 4 and 12. 4 and 12. So there's a bit to try and keep track of here. These values are changing. You got to follow the code. I mean, these are challenging. I mean, I don't know how you pull this off without writing stuff down. Even writing stuff down, I was struggling. Okay. So the next one says 2122 refer the following. Consider the method check number. And it says checks the validity of its 4-digit integer parameter. So this says Boolean check number. So this is checks the validity of its 4-digit parameter. So this is saying this is what it takes. Takes a 4-digit number and it returns true if n is valid, false if otherwise. So we got to figure out what does valid mean. A program invokes the method check number with the statement Boolean valid equals check number. Which of the following values in num will result in valid having a value of true? Well, this has to return true. And this says that remainder equals check digit. Well, it's just they're giving us some different values here. We could just try it and I would just plug one in and see what happens. So we're giving it 6143. We can just try it and kind of trace the code and see what happens. Says, so it creates these variables D1, D2, D3, check digit, in remaining, and rem for remaining or remainder maybe. Strip off the digits. So what does this do? This says, okay, well, 6143 modulus 10. Well, if you divide by 10, the remainder is going to be the 3 right here, right? And so that's what check digit is now. And then in remaining is going to be 6143 divided by 10, which is going to be 614. So that's in remaining. And then D3 is going to be in remaining, which is 614 modulus 10. So that's going to give you a 4. So it gives you D3. And then in remaining is going to be 614. So in remaining equals itself divided by 10. So it's 614 right now, divided by 10 is going to be 61. So that's now in remaining. And then D2 is going to be in remaining. 61 modulus 10 is going to give you a 1. So that's D2. and then in remaining is going to equal itself divided by 10, which is going to give you 0 for in remaining. And then D1, let's see if I did this right. I feel like I made a mistake here. Let's see, D2, 61 modulus 10. And then this is going to be 61 divided by 10, so it's going to be 6. And then 6 modulus 10 is going to give you 6. So that's going to be D1. And now we're going to check for validity. So does D1 6 plus D2 1 plus D3 4 add up to something? Well, we're gonna divide it by 7 and get the remainder. So this is gonna be 7. That's gonna be 11 modulus 7. So the remainder is going to be 4. And then it says, is the remainder 4? Does it equal the check digit at the beginning was 3? So check digit is the last digit, right? And this is false for that one. So we're trying to get the one that's going to be true. Now, can we kind of figure out what it's doing here so that we don't have to go through all that code? It looks like, check digit is going to be the last number. And then remainder is going to be all the other digits added in modulus 7. So for instance, this one, if we add these, that's going to be 11 modulus 7, which is going to give you 4. And then we're going to compare it to the last number 4. Well, that's true. So that one looks like it works. You try the other one. So this, I feel like, was more of just like trying to figure out what it's doing and not have to go through all those steps every time. Like I kind of figured out what we're doing is, so we're stripping off the digits. You're pulling one digit. D1, D2, D3 is the first digit, second digit, third digit. Check digit ends up being the last digit, the fourth digit. So this one, you get 11 modulus 7 equals 4. Does that equal the last one? Nope. Right, this one was 6 plus 1. It was 11 modulus 4. Modulus 7 was 4. Did that equal 3? Nope. This is going to be 11 modulus 7 equals 4. Does that equal 6? Nope. This one would be 11 modulus 7 equals 4. Does that equal 7? Nope. So I just kind of felt like going through the code helped me make sense of what we were trying to do, and then I kind of just applied it much quicker in these other ones. 22. What is the purpose of the local variable in remaining? So in that code, what does in remaining do? Well, I think it like holds the rest of the digits. It says it is not possible to separate in into digits without the help of a temporary variable. So it's kind of saying we need to keep what's left to be able to get each next digit. Sounds good, but a lot of these might sound good. In remaining prevents the parameter num from being altered. I guess, like, but I don't even feel like I see num in there. I don't know. That's kind of weird. Oh. Num is the value that's passed to it, which is just called in. I mean, again, that feels like true because if we were okay with getting rid of letting in change, then, that could be fine. C says in remaining enhances the readability of the program. I guess. D, on exiting, the value of n remaining may be reused. No, for sure not. Once you exit the method, that was a temporary variable. That one's for sure wrong. In remaining is needed as the left-hand side operand for integer division. In remaining is needed as the left-hand side operand for integer division. This one's kind of hard. In the most vague one, it ends up being C, but I don't know. Or you can read the Baron's explanation and see if it makes more sense. What output will be produced by this code segment? Ignore the spacing. Okay. I guess ignore the spacing in these. So I would start to go through and just kind of start reading, figuring out what's going on here. Maybe we can figure out a pattern and not have to do it all. But one option is to start going through. So I equals 5 first, right? And 5 is greater than or equal to 1. And then j equals 5, right? And 5 is greater than or equal to 1. Okay. And these are going to get decremented, which is kind of interesting. Maybe haven't done that a ton with for loops. System dot out 2 times j minus 1. So that's going to give us a 9. Okay. And it prints it out. And remember, if there's no curly braces, it's just the very next line that's going to be inside of it. So this one's after this for loop's done. Now, so we're still in this for loop, and j gets decremented. So j equals 4 now. And it wants to print 2 times 4 is 8 minus 1 is 7. Now, these are going to be on the same row because the ln is next. So this is going to print a whole row of stuff. 9, 7, then j equals 3. 2 times 3 is 6, minus 1 is 5. And then j equals 2, and 2 times 2 is 4, minus 1 is 3. And j equals 2 is still greater, and then j equals 1. And so it's going to be 2 times 1 is 2, minus 1 is 1. So this is going to be the first row. I wrote it as a column with the first row. So 97531, 97531, 97531, 97531. These ones are going to be out then, right? So narrow down a little bit. Let's go to the next one. So now I gets decremented to 4, and we go back here, and j equals whatever I is 4. And it says, okay, 2 times 4 is 8, minus 1 is 7. It prints a 7 out. This is going to be the second row, by the way, because this caused it to get bumped down to the next row after that first one was all done. J equals 3, it's going to give you 5. J equals 2 is going to give you 3. J equals 1 is going to give you 1. So it printed 7531. Now, it didn't print any extra space, so essentially we're just losing that first number. So 7531, I think it should be this one. I'm thinking it's got to be this. And you could keep going and confirm it, but I think I feel pretty confident with that. So this one has like a bunch of negatives or something, or I don't know what that is. So anyways, I think that's good. So 24, which of the following code fragments will produce this output? So this is kind of going backwards. Last time I gave you the code and said, well, which output is it going to be? And this time we're saying this is the output we want. So which code will do that? And all of them could work. These are notorious problems in calculus because it's like 3 problems in one. In computer science, it's, it can be tough just doing one of these problems. So I think we just need to kind of work through and see what happens with these. I equals 1 the first time. I equals 1. And then there's a for loop inside. So k equals 1. And it says if k equals I, which it does, print 2 times the k value. So it's going to print a 2. And then it's going to go to k equals 2. And there's no new line yet. And so k equals 2. Does k equal 1? No. So if it doesn't, it just prints a dash. And then it goes to k equals 3. and it doesn't equal 1, so you get another dash, and then it goes to k equals 4. And you get another dash, and k equals 5, and you get another dash, and k equals 6, and you get another dash. So far so good. That matches that, right? All right, so then I goes to 2, and k starts back at 1. And we get a new line here, so we're going to the new line. So k equals 1. Does k equal I? No. So we get a dash. And then k equals 2. Does k equal I? Yeah, they're both the same. So we're going to do double whatever the k value is. So that's going to be a 4. And then it's going to go to k equals 3. Do these equal? Nope. Dash, 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 dash. And then you're going to go to I equals 3. And k equals 1. And you're going to get a dash. And k equals 2. And you're going to get a dash. And k equals 3. And you're like, they match. So we need to double that value, which is 6. And then dash, dash, dash. So I think you can start to get the pattern here. This one seems like it's going to work, right? I mean, because we're going to keep going. Dash, dash, dash. 2 times 4 is 8. Dash, dash. And then dash, 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 dash. And 2 times 5 is 10. Dash. And then dash, 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 dash. 2 times. So that, I think this one's good. But there might be multiple ones that work. So this next one starts with I equals 1. And k equals 1. So it seems very similar, but then there's something weird right here. This is kind of the weird part compared to the last one. And it says, okay, well, starting at k equals 1, as long as k is less than or equal to I minus 1. Well, I minus 1 is 0. So is 1 less than or equal to 0? Nope. So that doesn't happen at all. This is all inside that for loop. So we immediately go to this and we print out 2 times 1 is 2. And then starting at k equals 1, it prints these dashes afterwards. So this k equals 1 was done. Now it's k equals 1 again. And then k equals 2, and k equals 3, and k equals 4, and k equals 5. And that's it, because once k equals 6, that. Oh, this is 6 minus I equals. So this is going to be 5 that time. Okay. So then you go to I equals 2 and k equals 1. And it says, well, while k is less than or equal to I, 2 minus 1, well, it's going to, once, it's going to print a dash. Then it's going to go to this, print 2 times whatever the k value is. 2 times the I value. So that's going to be 4. And then it's going to go back and say, okay, well, k equals 1 again. And let's print dashes until it's to 6 minus I, which would be 4. So you're going to get 1, 2, 3, 4. So this is interesting. It seems to be giving the same output, but in just a different way, right? When I equals 3, k equals 1, and it is less than 3 minus 1 is 2. So you get a dash and then a dash once k equals 2. And then it goes and it prints 2 times the current I value, which is 6. And then it goes here and starts at k equals 1 again. And does dashes until 6 minus I until 3. So dash for 1, dash for 2, dash for 3. So I think this one is working too. All right. Let's check this last one out. I equals 1, k equals 1. So this seems to be doing kind of the same thing right there. The major difference looks like that right there compared to this. So we kind of know, okay, k equals 1, I minus 1 is 0. Nothing happens. Go directly to this. 2 times 1 is 2. And then it goes back to k equals I plus 1. Well, so it's going to start at k equals 2. And it's going to print a dash. And then 3, and dash, and then 4, and then dash, and then 5, and then dash, and then 6, and then dash. Then I is going to go to 2. And it's going to say, okay, well, is k less than or equal to 2 minus 1 is 1? Yep. So we get a dash. And and then k equals 2, and 2 is no longer less than or equal to 1. So then we print out 2 times the current I value, which is 4. Then we go back and we set k equal to I plus 1. So now k is going to start at 3 dash 4 dash 5 dash 6 dash. This one's looking at all work. Oh my gosh. Those problems are tough. I mean, it's a lot of work. It's like 3 problems in one. Okay, 25. Consider the program segment. Int new num equals 0, and you have another int temp, and then int num equals k. What is k? K is some predefined integer that's greater than or equal to 0, so it's non-negative. While num is greater than 10, do this. Temperature equals num modulus 10. Num equals itself divided by 10. New num equals new num times 10 plus temp. Print out which is a true statement, which is a true statement about the segment. And this is another one that's real numeral, and so they could all be true. If num is between 100 and 1,000 at first, the final value of new num must be in the range of 10 to 100. I don't know. Let's just try it. It's between 100 and 1,000. I'm going to do 101. So 101 is greater than 10. Temp is going to equal 101 modulus 10, which is going to give you 1. So it's going to be your temp. And then num is going to equal 101 divided by 10, which is going to give you 10. And then new num is going to be new num, which is 0, times 10 plus temp. Okay, so now new num's that, and then goes back up here, and num is now 10. So while 10 is greater than 10, well, it's done, and this is all it's going to do. It's going to just print out 1, which tells you that this first one's false because it said it had to be 10. 2 says there's no initial value of num that will cause an infinite while loop. So infinite while loop is the while loop will keep going, meaning num wouldn't eventually get less than or equal to 10. So if num starts at like 1,000, you keep dividing 10 out of it, it's going to get smaller, smaller, smaller. So I would say that one's false. Or I don't know. No, I'd say that one's true because there is no initial number that will cause it. I think they all work. And then the next one says if num is less than 10 initially, then new num will have a final value of 0. Let's just try it. If you put 9 in here, temp is going to be 9 modulus 10, which is going to be 0. And then new num, this will be 9 divided by 10 is 0. And then you're going to print out the new num equals itself times 10 is 0 plus 10, which is 0, is going to be 0. So, I mean, you could try some other values, but this one's going to work. So it's going to be 2 and 3. All right, last one for this bracket. Consider the method reverse. It says that n has to be preconditioned. That means that that's for sure true. N is greater than 0. And postcondition is what for sure should be true after it's done. So it returns n with its digits reversed. Example, if n equals 234, it'll return 432. So they're telling you that's what it's supposed to do. Which of the following replacements for code segment would cause the method to work as intended? So, we could just try it with this example. and see how it works. So let's see. So int, there's some variables here, and then this has a for loop. So if we do 234, let's just try it. 234 is the in value, right? So that's what it goes right here, 234. And then it says, okay, remainder is, so n equals 234, and I equals 0, which is less than or equal to 234. Yep, so the for loop will work. And let's see, what does it do? It says remainder equals the in value modulus 10. So that's now going to be, remainder is going to be 4. And then rev num is going to be rev num itself, which was 0 times 10, which is 0, plus the remainder, which we got just now, is 4. And then n is going to equal itself divided by 10, which is going to give you 23. And then we're going to go back up to the top. I equals 1 now. N equals 23. Is I equals 1 less than or equal to 23? Yep. So the for loop continues. So then remainder equals 23 modulus 10 is 3. And then rev num equals itself, which is 4 times 10 is 40, plus 3 is 43. And then n equals itself divided by 10 would be 2. So you can go back up here to n equals 2. I equals 2 now. Is I less than or equal to n? Yep. So remainder is going to equal n modulus 10, which is 2. And then rev num, which is for reverse number, I think, is going to equal itself times 10, which is 430, plus that. So it's going to be 432, and then n divided by 10 is 0. You go back at the top, n equals 0. I equals 3 is less than or equal to 0. Nope, we're done. So we're done. Now that one seemed to work. That one did reverse them, you know. I'm almost thinking the thing that you got to watch out for here are like maybe special cases of where it wouldn't work, some special case. You know, I mean, if we go through all these, I bet they're all going to seem like they work in general. But the hard thing is sometimes they don't work for certain cases. So this is, we could try n equals 234. So doesn't equal 0, that's true. Then remainder is going to be itself modulus 10, which is 4, and then rev num. I mean, this looks exactly like this other one, right? So rev num equals 4, and n equals 23, and then n equals 23, which is not equal to 0. So remain equals 3, and rev num equals that times 10 plus that is 43, and n equals 2. So n equals 2, which is not equal to 0. Remainder equals 2. Rev num equals 432. And n equals 0, which now equals 0. So that's it. That's rev num. So that one seems to work. This one starts at the remainder 234 and says, well, it's not equal to 0, do this. Okay. This is I is going to be modulus. So I equals, so n equals 234. So then I equal remainder equals I, which is 234 modulus 10 is going to be 4. And then and this one has a rev num is going to equal 4. And then we go back up here, and what happens to I is it's going to be 234 divided by 10 is 23. So now I equals 23. So I started with 2, 3, 4. Now I equals 23 is not equal to 0. We're going to do remainder equals that modulus 10 is going to be 3, and then rev num is going to be previous value times 10, so 40 plus 3 is 43. And then I is going to be 23 divided by 10 is 2, which doesn't equal 0. So remainder equals I modulus 10 is 2, and then rev num is going to be equal 432, and I is going to equal 0, and it's done. So they all seem to work, okay? The big thing is if there's some kind of like special case where they don't work. And so you got to look at what keeps it going, like what keeps this going as you're doing this. I mean, this is really hard to spot. But for example, if we did n equals 134, and like on this first one, I equals 0 is less than or equal to 134, and that's true. So then remainder equals that modulus 10 is 4, and rev num is going to be 4, and n is going to equal itself divided by 10 is 13. So you come back up here and n equals 13, and I equals 0 is less than or equal to 13. So remainder equals n modulus 10 is 3, rev num equals 43, n equals itself divided by 10 is 1, n equals 1, I equals 0 is less than or equal to 1, remainder equals itself modulus 10 would be 1, rev num be 431, and n would equal 0. Okay, so I should have been going up on this one. I equals 2, it still works. I equals 1, still works. I equals 2. This would have never happened. So that's the flaw here. If you have a number that's less than the number of digits, if the first digit is less than a number of digits, then you're going to get in trouble. So once the digits are less than, so as long as this is like the 0th digit, the first digit, and the second digit. If any of these numbers are less than their spot, so if there was a 0 here, it would mess up because, you know, this is 1 is less than 2, then it messes up. So this one's not going to work. The other two still work. So it's going to just be 2 and 3 only. But that one's a hard one. I mean, those are just, I think I told you, these multiple choice questions are going to really test your attention to detail and knowledge of how Java works. So hopefully this is some good help.